Hello, today we're going to be looking at simple versus compound interest. And you might think, why are we doing this? We've just been talking about exponential equations. This doesn't make sense. Well, one of the most used applications of exponential growth or decay is compound interest. As you can see here in our compound interest formula, we do have our variable t up in the exponent, which is what makes it exponential. So this is basically a special version of our exponential growth formula. However, it's easier to think about interest first by talking about simple interest, which you've probably seen before, maybe even in middle school. But I want to kind of touch base on that just to kind of get the idea of interest back in your head. So, interest is the amount your money earns in an account just by having money with the bank. In past years, you used to be or a lot more interest on savings accounts. Right now, so not so much. Interest can also be charged to you, like if you take out a loan or when you use a credit card. If you keep the balance going from month to month, then the credit card company charges you interest for you basically spending their money. So, anyway, today we're going to not worry so much about those concepts, but instead how interest is calculated. So, when do you use which one? The problem will usually tell you which one to use. If the problem says something about using simple interest, you're going to use the simple interest formula. With simple interest, interest is only calculated and added on once at the end of the time period. A lot of times it's multiple years. If you look at the simple interest formula, A, the amount of money you have at the end of whatever time period, is P, your principal, plus that principal again times your rate as a decimal, just like we saw with our exponential growth and decay word problems, times the amount of time. Time always is expressed in years for the simple interest formula. If you're dealing with compound interest, that means the interest is added on, calculated and added on multiple times, usually multiple times per year, and then every year following that same pattern. The P, the R, and the T work the same way as they do in the simple interest formula, but you also have the variable N here. The variable N is how many times per year the interest is calculated and then added on. In this table here are some words that are often used to describe a N frequency, basically, and then what that N stands for. You're probably familiar with a lot of these words from just seeing them in your day-to-day life, but just as a friendly reminder, monthly, since there are 12 months in a year, will be N equals 12. Semi-annually means something that happens twice a year. Quarterly, there are 4 quarters in a year. A lot of times businesses talk about things in terms of quarters, so there would be N equals 4. And daily, we just always use 365, even if it's a leap year. So just don't worry about whether or not it's a leap year. N is always going to be 365 if you're dealing with daily. Let's try a few of these things out. I want to show you how to use Desmos with these things too, though. So I'm going to get rid of this part here. So before I get rid of this part, let's write which formulas we're going to use for what. Number 1 and 2 tell us to use simple interest. So we're going to use the simple interest formula. A equals P plus P R T. The other two say find the total value of the investment. How do you know they're talking about compound? You know they're talking about compound because you see this compounded. Anytime you see the word compounded and then something like monthly or quarterly or whatever, that's how you know you're using compound interest. The compound interest formula I'm going to write just so we can look at it when we're looking at these problems. P1 plus R divided by N to the N times T power. Let's try some of these out. So for number 1 and 2, we're going to use the simple interest formula because they tell us that's exactly what's going on. I like to label the numbers here. P is the amount of money we're starting with. So for number 1, that's 6,300. R, remember to switch a percent into a rate, we move the decimal 2 places to the left, 1, 2. So 1% becomes 0.01. My handwriting's bad today. And then T is your number of years. So for number 1, T is 6. So I like to write my formula out with everything plugged in. It's going to be P is 6,300 plus P again, 6,300 times my rate, 0.01 times the time, which is 6. With all of these, you're going to end up with some things that you don't necessarily want to do in your head. So I would strongly recommend using a calculator. I'm going to show you Desmos. Desmos, as usual, just type in everything after the equal sign, 6,300 plus 6,300 times, you can use the times dot or you can use parentheses, doesn't matter here. I like parentheses because my handwriting's a little sketchy today. And Desmos will calculate that for us. We get $6,678. So with 1% interest after 6 years, our account is now up to $6,678. Same idea for number 2, but this time our principal is $19,800. Our rate, if I switch that to a decimal, is going to be 0.07, and then T is 2. So we do 19,800 plus 19,800 times our rate, 0.07, times our time, which is 2. So then Desmos that up. Make sure you're typing things in correctly. That's pretty much the only way you can mess these up. And of course, I've modeled what it looks like when you type things in incorrectly there. And so Desmos tells us when we do all of those calculations, we get 22,572. So after 2 years with that lovely 7% interest rate, your account has grown by almost $3,000. 7% interest rate, unfortunately, is not going to happen in any bank accounts in this day and age. However, credit card companies would be more than happy to charge you much, much more than 7% interest. So interest works in your favor when you're earning it, but very much against you when interest is being charged to you. Alrighty, so then number 3 and number 4, since we see the word compounded in here, that's our clue. We're going to use the compound interest formula. So in number 3, our principal is $37,000. Our rate, when we switch it to a decimal, is going to be 0.05. And compounded monthly, there are 12 months in a year. So N is going to be 12. T is our number of years, which is 8. So filling things into our formula, it's going to be 37,000. 1 plus our rate is 0.05. N is 12. And then our exponent has 2 things being multiplied together in it. So I'm going to put parentheses around that. It'll help us when we go to put in Desmos 2. N times T means it's going to be 12 times our number for T, which is 8. So then let's very carefully type that all in the Desmos. 37,000, 1 plus 0.05. Use your division key to make that into a fraction, divided by 12. Close your parentheses, or go to the outside of your parentheses. And then to get your exponent here, remember it's a to the b to get up into the exponent. And then parentheses, because otherwise Desmos will get confused if you try to do multiplication up in the exponent. 12 times 8, that times dot is very important. And with compound interest, because of the division here, you're often going to get some sort of crazy decimal. We are dealing with money here, so we're going to round to 2 decimal places. So our final answer here is going to be $55,151. And then our amount of cents, 66.662, is going to round to 66 cents. So in 8 years, we go from $37,000 to over $55,000. 5% interest rate is a very nice interest rate. And also when we're adding on interest every month, it's going to really add up when we compound it monthly. Let's try one more. So starting amount here is 16,500. When I switch 2 into a rate decimal, that's going to be 0.02. Compounded quarterly. Quarterly is 4 times a year, so N equals 4. T is once again 8, just a coincidence. T won't always be 8. So filling things in, 16,500, 1 plus our rate, which is 2%, 0.02. This time N is 4, so divided by 4. And then parentheses for your exponent, 4 for N times your T, which is 8. So then let's practice typing everything into Desmos one more time. 2,500 parentheses, 1 plus rate is 0.02. divided by 4, and click on the outside of your parentheses, hit your A to the B button, make a new set of parentheses for your exponent, 4 times 8, and then we're going to round that to 2 decimal places. So our ending amount is $19,355, and 0.211 rounds to 0.21, so 21 cents. So use Desmos, definitely for these. Be very, very careful about how you type things in Desmos. Use your parentheses. Make sure what you're typing in looks exactly like what we have here. That is it for today. Have a wonderful day.